Welcome to True Projects. In this video, we are going to explain about the project that is integrating sentiment analysis with machine learning for cyberbullying detection on social media. So, before getting into the execution, first let us understand what is the project about. Social media, which has completely changed the way people communicate and share ideas. Platforms like Twitter, Instagram, and Facebook allow individuals to post thoughts, share opinions, and interact with a large audience instantly. While this has many advantages, it has also created a space where cyberbullying can occur. Unlike bullying in schools or workplaces, cyberbullying happens online, which means people can hide their identity, target others anonymously, and reach a much wider audience. This makes it more dangerous because harmful messages can spread quickly and affect multiple people at once. For example, a single negative post about someone can be shared hundreds or thousands of times, causing emotional stress or even depression for the victim. So, detecting cyberbullying is not easy. Online language is very different from normal speech. It often includes slang, sarcasm, or coded words that are meant to hurt someone without being obvious. For instance, a comment like, nice outfit, did your grandma pick it? It might seem harmless at first glance, but it could be a form of subtle bullying. Similarly, hashtags or abbreviations can hide abusive content that is hard to detect automatically. Traditional machine learning approaches try to identify such messages, but they face two major challenges. First, they require a lot of computational power to process massive amount of data, and second, they often fail to understand emotional tone behind a message. This means a system might incorrectly label a joke as bullying or miss a genuinely harmful content, that is, miss genuinely harmful comment, making the task of detecting cyberbullying both complex and also crucial. So, here, another big challenge is in detecting cyberbullying comes from the way the data is distributed in these datasets. Not all types of bullying are equally common. Some, like insults about someone's age or religion, may appear frequently, while others, such as subtle gender based comments or rare forms of harassment, might be much less represented. So, this imbalance can cause machine learning models to become biased. They perform very well on common types of bullying but fail to detect the rarer ones. For example, if the dataset mostly contains offensive comments about religion, the model might learn to focus only on that and ignore much subtle or less frequent forms of abuse. And the another issue is that balancing accuracy, precision, and recall is difficult. A model might incorrectly flag harmless or critical feedback as bullying, or it might miss real bullying messages. For instance, a sarcastic comment like great job on that project's genius. It might confuse a model if doesn't understand context or tone. These challenges show why we need a more reliable and efficient detection methods. Systems that can adapt to the constantly changing language on social media, reduce mistakes, and fairly detect all types of cyberbullying, even those that occurs less frequently. So here, to overcome with all such issues, this project it is designed to identify cyberbullying on social media by combining sentiment analysis with the machine learning. Sentiment analysis it allows the system to understand the emotional tone of a message, whether it is positive, neutral, or negative, which is crucial for distinguishing between abusive content from a normal interactions. For example, a comment like "You're such a loser" would be flagged as a negative and potentially harmful, whereas "Good job on your presentation" would be recognized as positive or harmless. And here, to make the system effective, the text data is carefully prepared by using pre-processing techniques. This includes normalization, that is making all text consistent, such as converting to lowercase, lemmatization, that is reducing words to their root forms like running to run, and TF-IDF vectorization, that is a method to quantify the importance of word in the dataset. These steps help the model understand the context and meaning of words better so it can accurately identify abusive or harmful messages even when language is subtle, sarcastic, or complex. And one of the main challenges in cyberbullying is that Some types of abusive content appears much less frequently than the others. So to overcome with that, this project uses synthetic minority oversampling technique, which generates synthetic examples of underrepresented categories. This ensures that all forms of cyberbullying, whether common or rare, are fairly represented during training. For instance, if gender based harassment appears less often than offensive comments about religion, SMORE helps the model learn patterns from both the categories equally. And then system also employs variety of machine learning models such as logistic regression, random forest, support vector machine, XGBoost, gradient boosting, extra tree, naive Bayes, decision tree, and AdaBoost. So by combining these classifiers with the sentiment analysis, pre-processing and resampling techniques, the model becomes capable of accurately detecting different forms of cyberbullying. This integrated approach helps to ensure that harmful content is identified reliably, making online platforms safer and protecting users from potential emotional or psychological harm. And moving on, to further improve the performance, that is to make the cyberbullying detection system even more effective, several enhancements are added to improve its performance, transparency, and usability. So, first, the system incorporates Smotin technique, which not only balances underrepresented classes but also cleans the data. And an additional ensemble approach is applied to make the model more robust against diverse types of cyberbullying. And then some explainable methods like LIME and SHAP are used to understand which features or words contribute to the model's predictions. This helps in interpreting model's decisions, ensuring trust in its outputs. Third, voting classifier has been implemented in this project. So this voting classifier, it combines multiple machine learning models. So it combines MLP and bagging with logistic regression. It is implemented to further improve prediction accuracy by leveraging multiple models together. And the other model is latent dirichlet analysis. So here we have implemented latent dirichlet allocation to discover hidden topics and themes within cyberbullying text data. This helps to identify common patterns, recurring phrases, or underlying subjects in the abusive messages, providing deeper insights into the nature and context of the cyberbullying content. And additionally, here we have developed front end by using Flask framework. So we have used Flask framework to develop a user-friendly interface with the user authentication mechanism. It allows users to input text, get predictions, and interact with the system securely in a user-friendly environment. Moving on to the implementation. To implement this project, here we have followed the steps which are mentioned in the flow of work. So let's understand how we have implemented this project. First, we have developed backend model where all the necessary Python libraries and modules are loaded to enable data processing, model building, and evaluation. Then comes exploratory dataset. So the cyberbullying dataset is examined to understand its structure, content, and the class distribution. Then comes preparing the dataset. So here text data is cleaned and standardized to make it suitable for machine learning models. Here, all the text is converted to lowercase for consistency and emojis are translated into text to retain emotional context and URLs and special characters are removed to reduce noise. Tokenization splits text into individual words or tokens. Stop words which do not add meaningful information are removed, and lemmatization has been used, which reduces words to their base forms to unify similar words. Then comes data visualization. So here in the step, techniques such as bar plots for class distribution and word clouds are used to understand patterns and highlight frequently occurring terms. Then comes TF-IDF vectorization. So here we will be converting the clean text into numerical vectors based on word importance, allowing the model to process textual features effectively. Then comes label encoding. So here we will be converting categorical labels into numerical forms for machine learning algorithms. Then comes resampling the input. So here we will be using smooth technique that is applied to balance underrepresented classes, ensuring that model learns patterns from all the types of cyberbullying fairly. Then we split the data into train and test sets. Train set is used to train the model and test set is used to evaluate the trained model. And then comes model building part. So here multiple machine learning classifiers are trained using grid search CV to final, that is to find optimal hyperparameters for the better performance. And all the models are evaluated using these metrics, and that performance scores are generated graphs. That is, we will be generating graphs for those performance, and we will be evaluating which model has been achieved the highest performance, and we will be saving that model for the future prediction. So we will be saving that model using joblib. And coming to this xai part, here we have used tools like lime and shap to explain which features influence the model's decisions, enhancing transparency and trustworthiness. Coming to front end part, so here we have used a user friendly front end, and that is developed using Flask framework with registration and login functionality supported by an SQLite database for secure access. Then comes user gives us input. So here users they provide text for prediction through the interface that will be pre-processed at the backend. It will be fed to the train model, and then train model will be giving us the prediction, predicting the cyberbullying, whether the text is cyberbullied or not. Moving on to the algorithms used. These are the algorithms which are used in this project for detecting cyberbullying. To implement this project, we need two kinds of requirements, which are hardware and software. In hardware, we need operating system of Windows, processor of 5 and above, RAM of 8 GB and above, and hard disk of 25 GB and above. Software are application of Anaconda, primary language of Python, front-end framework of Flask, back-end framework of Jupyter Notebook, database of SQLite 3, and front-end technologies are HTML, CSS, JavaScript, and Bootstrap 4. So this is the overview of the project. Now let's execute it. To execute, let's open the code folder of the project. So these are the source code files. Let's understand each of them. Here in this folder, we have the dataset that is used. Let's open it. So this is the dataset that we have used for training the models for predicting cyberbullying text. So here we have different text, and here we have type it belongs. So that is whether it is cyberbullying or it is not cyberbullying, or which type of cyberbullying it is. Close this, get back. This is the model folder in which we have algorithm information that is stored in .h5 files, numpy files, and pickle files. They will be loaded into the project code during runtime of the application. And here we have static folder which contains CSS, JavaScript, and Bootstrap files which are important for the visual appeal. And here we have templates folder. It contains all the HTML pages used in this project. It typically includes files like index.html, about.html, etc., which represent different pages of the website. And next we have test cases file in which we have test cases that we will be using in the front end. And here we have app.py file. So this .py file, it contains the information related to front-end logic. It includes code written in Python that handles server-side operations such as processing user requests, interacting with the database, and generating dynamic content to be rendered in HTML templates. And this is the Jupyter Notebook file. So it contains combination of code, graphs, and outputs all in one place. It allows users to write and execute code in individual cells, making it a popular choice for the data science. And this is the signup.db file. This is a database file which is used to store the user information. And this file is about code related to topic modeling, where we will be using later direct analysis to extract the important patterns in the words. So this is all about the code folder. Now let's execute. So copy the path of the code folder from the address bar of the file explorer. I've copied it. Now open Anaconda prompt. So it is open. Give the command cd, give the space, paste the copied path. Now click on enter. Here, if you observe, current directory is changed to the code folders path. Now compile app.py file. So give the command python space app.py and click on enter. This command will execute Python script and perform a runtime check for any syntax errors or logical issues. And after running the app.py file, Flash framework will host the application locally at the default address, which is the local host and the port unless configured differently. So this is the address where application has been hosted. So copy this link provided by the Flask framework and paste it into any web browser. I've copied it. I prefer Google Chrome, so I will paste it in that. Paste the link here and now click on enter. This is the web page of the project which is displayed in the browser, and this is developed using Flask framework. So we need to get registered first. So click on register and enter the given credentials to create an account. I have already registered, so I will directly sign in. Click on sign in. Give your username and the password and click on sign in. We have signed in successfully and redirected to prediction page of this project. So this is the prediction page. And if you click on explore us, it will navigate to a text box wherein we need to give the input message. For that, let's open the text box, that is test cases. So open test cases, open samples file. So drag this tweet text and let's apply filter to the class that we will be predicting. So let's apply filter to it. Now let's apply filter to class age. So select it, click on OK. Now select any text from the given, select it, that is copied. Now get back to the application, paste the text, and now click on submit message. So this given input will be pre-processed at the backend. It will be fed to the train model, and then train model will be giving us a prediction. So here we got the prediction that it is age type of cyberbullying it is, and here we got the prediction that it is this message is related to age-based cyberbullying. And here information it is giving is that be aware of age-related discrimination and report if necessary. And these are the words that are important, that is top keywords for this text that we have given. Now close this. And now let's give the another message. Apply filter to ethnicity. Click on OK. Let's try with this one. Get back to the application, paste it, and now click on submit message. So here we got the prediction that it is ethnicity related cyberbullying. Here it is giving the warning that this message is related to ethnicity based cyberbullying, and it is specifying that ethnicity, that is ethnic bullying, is serious. Consider reporting and seeking a support. And topic for the paragraph is dependent upon these words. Based on these only, this prediction has been made. Now let's close this and try with the other message. Get back to the application, paste it, click on submit message. So here also we got it as ethnicity. Now close it. Let's try with the other classes. Click on explore. Let's filter gender-based cyberbullying text and see whether the application will correctly predict it or not. So select the text, get back to the application, paste it, and now click on submit. Here, if you observe, we got prediction as it is gender type of cyberbullying, and it is mentioning that this message is related to gender-based cyberbullying. And gender-based cyberbullying can be harmful. Reach out for help if needed. And these are the top keywords of this message that we have given. Now close it. Let's try with this one. Get back. Paste the message. So here, if you observe, here also we got the prediction as it is gender-based cyberbullying, and these are the top keywords which are extracted using latent directlet allocation. Now let's try applying filter to the other class. Select non-cyberbullying. So I'm selecting the first one, paste it. Now click on submit. So here, if you observe, it is not a cyberbullying message. No action is needed, so you can continue using social media. And these are the top keywords of it. Close it. Let's try with the other one. Let's try with this one. Paste the message. So here also we got it as not cyberbullying. Close it. Let's check with the other class, that is other cyberbullying. Click on OK. Now let's check with this one. Paste the message. Click on submit message. So here we got the prediction as other cyberbullying. That is, this message is related to the other forms of cyberbullying. So it is telling to stay vigilant and report any suspicious activity if it occurs. So these are the top keywords. Now close this. Let's try with the last input message. Apply filter to religion. Click on OK. So select any one of your choice. Get back, paste it, click on submit message. So here it is predicting it is religious type of cyberbullying. This message is related to religion-based cyberbullying, and religious bullying is unacceptable. So it is telling to report and seek support if it is affected. And these are the top keywords. Now close this. Let's check with the graphs. Click on about. So here we have distribution data. Here on x-axis we have different types of class that we are predicting, and on y-axis we have number of outcomes. So this shows the class distribution of the target that we are predicting. Close this. And here we have word cloud. Close it. Here we have confusion matrix. This is confusion matrix. And here we have accuracy score, which is the evaluation metric. And here on x-axis we have all the metrics, and on y-axis we have accuracy score. Sorry, on x-axis we have all the models that we have trained. Similarly, we have for other metrics also precision, recall, and FN score. So these are the metrics used to evaluate the model. Close it. Now click on sign out. In this page, just by giving input message to the application will be predicting whether the text is of cyberbullying or not. If it is of cyberbullying, it will predict which type of cyberbullying it is. This is all about the project.
Thank you for watching video. For more projects, please visit our website www.trueprojects.in. For updates on latest project videos, please visit True Projects YouTube channel and subscribe.